Good morning or good whatever it happens to be, wherever you're from. My name is Magnus Hagander. I'm coming out of Stockholm in Sweden, so I'm at whatever o'clock right now, to the point of not really caring. But what I do know is we're here to talk about Postgres. We're here to talk about Postgres 14. So I like to say that a look at the elephant's trunk, a look at what's in Postgres 14. Who's already running Postgres 14? In production? Oh, come on.
I'm already running Postgres 15.
Yeah, but you don't run production. So you don't count. Also, you're well hidden behind the board here, so I can't see you there. That's probably for the best. So anyway, Postgres 14's been out a while. I've started to see it in production a bit, but we're still waiting on a bunch of people through that. So as I mentioned, my name is Magnus Hagander. I work for a company called Red Pill Linpro. We're an open source consultancy and services business in Scandinavia. So I'm based in Stockholm myself. We have offices all over Scandinavia where Postgres is one of the projects that we work around, or one of the products, I should say, in that regard, that we work around for our customers, doing consultancy, doing training, doing all sorts of things. We have hosting departments, stuff like that. Within the Postgres project, I'm a member of the core team. I'm one of the code committers. I am currently serving as the president of Postgres Europe, which do things like this event in Europe, except sadly we had to once again cancel our conference this fall. I'm very glad to get a chance to come here. There's been, I think, exactly one event in Europe.
Can you speak into the microphone, please?
Oh, speak more into the microphone. Okay, here we go. We've managed to do exactly one event in Europe so far. Hopefully we'll be coming back to doing more of these over time, and I'll get to pick up that one a little bit more. Anyway, Postgres and Postgres 14. And this time I actually get to say that we're done. That's good. I've given this talk before. If you've been coming to these Postgres events over the years, you've seen me do the new version of Postgres talk many times before, possibly. Last time I did this talk, we weren't actually done with Postgres 14. I'm happy to say that we are. And it turns out the majority of the talk that I gave on what was about to become Postgres 14 turned out to be Postgres 14. That's always a happy thing to know. So the development of Postgres 14 has been going on since June of 2020, when we branched off Postgres 13. The way that we work with the development in Postgres is we always do the new version development on the master branch, and then we at some point declare that we're ready with a version, and then we branch it, and we create the branch. In this case, we created a branch called release 13 stable, and then by magic, 13 was now stable, right? That's how it works. And at that point, we open up the master branch in the repository for building of what will be the next version of Postgres then, so 14. So this started in June of 2020. Then in Postgres, we work with something that we call commit fests, which is really just our way of doing cyclic development, where we do 1 month of writing code, and then 1 month of reviewing and committing that code. And that month of review and commit is what we call a commit fest. So Postgres 14 had 5 of them: July, September, and November of last year, January and March of this year. And at the end of this 5th commit fest at March, that was basically feature freeze for this version of Postgres. And then we spent the time from April to September testing it, putting out the beta version, things like that. And I think we said early on that we're going to target a release in September. We did manage a release in September, on the 30th of September, but that's still September. Technically, it may no longer have been September everywhere in the world when the release was actually made, but close enough. So it's been out there. We now actually have a version 14.1 that came out earlier in November. That is the latest minor version for 14. So if you are one of those people who were waiting for the first minor release, for the first amount of bug fixes to come out, they're out there, so now is the time to go upgrade. So let's talk about what is actually in Postgres 14. I like to group my features a little bit in the areas of DBA and admin, SQL and developer, specific then talk about backup and replication features, and obviously performance, because everybody loves performance. Usually they love better performance, but things that happen. So first, a couple of words about breaking changes. There are a few things in 14 that will break stuff. It is not like some versions we've had where we broke everything, but there are a couple of things to know. One thing is that we have changed the default authentication method in Postgres to be SCRAM SHA-256 instead of MD5, which is good for everyone in every way, except if you have really old clients that don't support it, they will no longer be able to log in. Now, SCRAM authentication was added to Postgres 10. So this basically means if you have client or client libraries that are older than Postgres 10, or the equivalent time, because of course Postgres 10 applies to the libpq built-in driver, but if you're using the JDBC driver or the .NET driver or something, you need also to be above a certain version. All of these major drivers have support for SCRAM, but you may need to upgrade. Of course, you can still, support for MD5 is still there, so if you upgrade and your system breaks, and you don't have time to fix it properly by upgrading your drivers, you can just change the configuration back down to being MD5. But you should really look at turning it into SCRAM. Now, the thing to know is that all your existing stored passwords are still stored with MD5. So your clients will be able to speak and will default to using SCRAM, but to actually take advantage of the security of SCRAM, you have to change the password of all of your users. It is backwards compatible, you can still use the old ones, but you need to change it to have it re-encrypted for storage on your server after this default parameter has been changed. Same applies, of course, if you want to enable SCRAM on a previous version of Postgres, you also would have to change all your passwords to take full advantage of it. Support for SSL compression has been completely removed. It is deemed as insecure by the people who know much more about cryptography than me. Basically, it has the idea of the interaction of cryptography and compression that can lead you to leak information to an observer. It is also true that for most people who were thinking you were using compression in the SSL library, it probably didn't work. Because over the years, since these vulnerabilities in the SSL protocol were found, more and more distributions of Linux, for example, have made it more and more difficult to use this. You have to put magic files somewhere, you have to change some magic environment variables and things, and if you don't do that, it just didn't work anyway because it was turned off. Like they would patch OpenSSL so that you couldn't enable it without doing these special hoops, which is kind of an interesting way of doing it, but that's where it is. And the newer versions of the TLS standard that are out now, there is no support for it in the protocol at all. So we're really just sort of preparing to follow with the others. The downside of this is this was the only way that we could compress the Postgres protocol, the Postgres data stream. So if you were sending data over a very slow and expensive connection, for example, we no longer have an answer. I mean, you can tunnel it through a VPN that does compression or something like that and making it somebody else's problem. But Postgres no longer has a solution for this because the one that we relied upon has been deprecated for years and has now finally been removed. We've also removed support for version 2 of the Postgres wire protocol. I really hope this is not going to affect anyone. This was last used actively in Postgres version 7.3. Who in here was using Postgres at the time of Postgres 7.3? Okay, that's actually surprisingly many. I mean, only about 2/3 of you are actual, Postgres contributors. There were other people too who were using it that long. It's a long time ago. If you run into problems because of that one, you may want to look at your more like overall upgrading strategy for your whole environment, probably, if you were relying on things that are that old. So anyway, those are things that have been removed and things that have been changed. Let's look at some new stuff. That's more fun. So in the area of DBA and administration, well, first, we now have something in Postgres called predefined roles. We had this before, we just called them default roles. But we've changed the name of this because really default roles is kind of a bad name for it, but that's what we had. They're now called predefined roles. These are roles that always exist in the system that will be granted certain amount of permissions automatically. So, for example, many of you may have run into, we have a role called PG monitor that is designed to grant to connections from your monitoring system to give it access to those specific things. That is now a predefined role. Otherwise, it works the same. We've added a couple of roles, though, that are really interesting. These are roles that I've seen extremely frequently requested by people who've come from the SQL Server world. For example, there's a role called PG read all data and a role called PG write all data. They will let you bypass permissions on the table to just read all, like if you grant PG read all data, that user can read data from all of your tables without you having to go and grant them specific permissions on that table. Obviously, these are fairly high privileges, so be careful with them, but it's still a lot better than, as unfortunately at least I've seen a lot of people do, just grant super user, because that's easier, right? And this is much better than granting super user.
Do they have a default privileges like on feature tables as well?
So these are attached to the role, so they're not attached to the table at all, and that's exactly one of the reasons to use them, right? They will grant you access to all tables today and tomorrow, and all over. There's another role that kind of works the other way around. There is a role now called PG Database Owner, which is automatically granted to the user that owns the database that you are currently connected to. That means that you can grant things to the owner of the database even without knowing who that is, because it'll update dynamically who it is. For example, if you create a database that is a copy of another database with a template, you might have a different owner, but you can still assign permissions that will come with it and come through it. There are some plans for using this for more built-in objects in the future, but in 14 it just is there. It is not actively used by the system yet, but we're hoping to see that in the next version of Postgres, which you will have to wait for a couple of more months. We have some enhancements of the SSL support. Other than just removing the compression, we've also added some things. We have support for SNI, the, what is it, server name identification or something like that. The idea is you can have a certificate with multiple names. libpq, when it connects, will by default tell the server which host name it is trying to connect to so that the server can present the correct certificate if you have multiple names for the server. Now, this is a very common scenario in the web world where browsers will use SNI to be able to multi-home multiple websites on the same IP address. This is basically the same for Postgres. And SNI is turned on in the client by default. You can turn it off. If you are super security conscious, you may want to consider turning it off, because the actual host name, so when you make an SNI connection, the client tells the server which server it's trying to talk to. That part is not encrypted because it has to see the certificate first. So you may leak the name of the server to an observer at that point. You still know the IP, so probably not super important, but it's something to consider. You can also now use the DN, or the distinguished name, of your certificate to log in. In previous versions, you could only use the CN, the common name, but now you can use the DN, which is the full path. You do this by setting client name equals DN on the configuration line in your HPA configuration. And now more than ever, you probably want to do a pgident user map so that you don't want your actual username in Postgres to be this long LDAP string, basically, or X500 string. You want to map it down to somewhere where your username is sitting. Speaking of connections, there is now finally, I think this may be one of the most requested Postgres features over many years. There is an idle session timeout. For a couple of versions, we've had an idle in transaction session timeout, that if you left a session with an idle transaction, after a certain amount of time, Postgres would cancel the transaction. But we've never actually had a way to cancel a completely idle session. It's just been sitting there. With idle session timeout, well, that's exactly what will happen. If you set this to, I don't know, 15 minutes, then if you have a session that doesn't do anything for 15 minutes, it gets killed. You'd think, well, the argument for a lot of people in Postgres has been, well, an idle session is not that expensive, but it can be. A classic example can be if it's holding temp tables, large amounts of temp tables. They don't get cleaned up until the session exits. And if it never exits, it turns out to be expensive. So you can now set the idle session timeout. You probably don't want to set it to something like 10 seconds or anything. Like you want your sessions to connection pooler and kill it after 10 seconds. No, we want persistent connections. This is more of a fail-safe. So you want to set it in the order of tens of minutes or something, I would guess. Yes. I haven't seen anyone yet who set it to 10 seconds, but I've certainly. Oh, does it tell? Yes, it will go in the Postgres log that it killed it. I think it sends I actually don't know. That's a good question. I think it sends an exception down, so you'll get an error that's similar to the, the administrator closed this connection thing, but I'm not entirely sure. It might depend on the connection pooler or the driver, whether it's consuming this before the connection goes away. whether it sees it or not. Another problem that you may have seen along idle connections or other connections in Postgres are simply hung connections, or what you would think is a hung connection. A classic problem is you start running a really long query and then the client goes away, and the query just keeps on running until it's done 2 days later, and then it realizes the connection is actually broken. You can now set a parameter called client connection check interval, where you can basically say if Postgres is running a long query, then go in every 2 minutes and see that the client is still there. Now this requires a special platform support. It's not supported on all platforms, but I would say importantly enough, it is supported on Linux, which will cover the vast majority of all installs where we actually care. I think it might be supported on FreeBSD, depending on version. I'm pretty sure at this point it is not supported on Windows. And at that, we've probably covered all the major platforms that people use. This will allow you to realize and abort these queries early. Obviously, if the connection is gone, it's gone, and we can't do anything with it. But there's no point to keep running a query if we're going to end up throwing away the result at the end anyway. There's a whole bunch of things that's been added to our statistics system. For those of you who've seen me do these before, you know I'm a big fan of getting more data into our statistics systems, or rather getting more data out of our statistics systems. It certainly has its problems, but getting the access to more data is usually good. There is a new view called PGStatStatementsInfo that holds a very important piece of information that was missing before, which is if you're not, first of all, if you're not using PGStatStatements, you should probably start using PGStatStatements. It'll give you an insight into your system that you really need. But the problem is that this view contains cumulative statistics like most Postgres views, right? It'll tell you this query has been run 150 million times. Since when? Well, yes. There is no way to find that out. In Postgres 14, there is now PGStatStatementsInfo, which will tell you when was this reset. So it'll tell you, oh, it ran 150 million times since yesterday. Okay, maybe I need to care about this query. Or it ran 150 million times since I installed Postgres. Maybe not as important, depending on when you installed Postgres. PGStatStatements has also received another column called top level. You have, for I think forever, but at least for a long time, been able to, in PGStatStatements, tell it whether you wanted to track just top level statements, or if you also wanted to track all statements. The example being if your top level statement calls a function and that function makes another statement, do we track those as independent statements? And you could set it to track all, in which case it would track them as independent statements, but there was actually no way to tell what type of statement that it was. In Postgres 14, you have this new column called top level, which will basically tell you whether this was a top level or a nested level statement. It's only a Boolean, so it doesn't tell you like how deeply nested it is, but it'll tell you whether it's a top level or not. And that is part of the unique key. Right? So you will see that if you have turned on PGStatStatements to track all queries, you will see the same query twice if it has been executed both as a top level and as a nested level function. Now, whether that's actually common to happen is going to depend on your application. There was a survey done prior to merging this feature, and I think that showed that something on average of like 1.5% or so of queries were ever actually run at both levels on whatever subset they used. But it's not super common. But if you do, just be aware that the same query can show up twice with this value being different. So if you are, for example, snapshotting this data somewhere, you need to include this Boolean field in your key. We have a new view called PGStatWall, which will give you statistics about your write-ahead log. How many records are written, how big are they, how many of these full page images are there, buffer flushes, writes and sync times, a lot of this data. And as with other stuff, it is cumulative. So you track it and you can make pretty graphs and you can realize when your WAL is doing something that it wasn't doing before, which is usually an indicative of something that you didn't expect. An additional to our set of progress views, there is now a PGStat progress copy. And you can probably figure out what it does, right? It gives you a progress report for any running copy statement. It'll tell you how much data has been sent in or taken out, how far along is it in the stream and things like that. Similar to how we've, over the past couple of versions, added statistics for vacuum or for create index and such. Now also copy, they're all very similar. For some very low level or deep level statistics, there is now a view called PG backend memory contexts, which will, for your backend, tell you exactly where memory goes. In Postgres, all the memory that is allocated into a backend is split into different contexts to sort of tag what it is and to decide when it's going to be freed. This will give you a very detailed view as to exactly where your memory has been allocated. Now, PG backend memory context will give you information about your backend. A lot of the time, it turns out, particularly if you're a DBA looking at a system that's misbehaving, you're actually more interested in what this other query is doing. Like somebody's been running a query for a long time that's using a lot of memory. Where is that memory? For that, there is now a function called PG log backend memory contexts, which does basically the same thing, but when you run that function, you give it the PID of a different session, and that session will write to the log file its memory contexts. Because we cannot in Postgres, like we cannot from one session peek into another session, but we can tell it to dump its state to the log, and then we go look in the log file, and we can see where it goes. I think for a lot of those of us who tend to get to poke at live systems where you can't just change things, the actual function to dump it to the memory is going to be more commonly useful, because then you can figure out, do you have an extension that's using memory that it shouldn't be, like where is it all coming from, as a step of debugging. The PGStat database view has been enhanced with session statistics, which tells you for each database how many sessions, so how many connections have come into this database since statistics reset. How much time has been spent running queries in this database versus idling in this database. And how has connections in this database ended? Have they been clean shutdowns? Have they been network errors? Have they been crashes, splits? And so we can get, again, cumulative statistics to see what's happening. And again, a useful thing, particularly for those of us who tend to end up looking into systems that's already been running and they're not necessarily our systems. So we don't have historical data, but we can go in and see, well, why have there been 1 billion connections to this database? This indicates that you either don't have a connection pool or your connection pool is misconfigured. Things like that will now be visible in PGStat database. It's not over yet. PGLogs view has gained a column called wait start. If a session is waiting on a lock, right, the lock will be not granted. There's a column in PGLogs that says granted. If granted equals false, we will now track how long we have been waiting for this lock. We have a timestamp of when we started to wait for this lock. Because waiting for a lock is perfectly normal, and if we've been waiting for a millisecond or two, it probably doesn't matter. It might sometimes matter, but most of the time it doesn't. If we've been waiting for hours, more likely to be a problem. So you have that information available in PGLogs. So that's a whole bunch of additional statistics that I think are going to help you get a better picture of what your system is actually doing. So let's take a look at the things on SQL and developer. And as I usually do in these, well, what's the difference between developer and DBA? Well, well, these are things that are exposed at the SQL level. So things that you do through SQL. Other than that, it's really a blurred view, right? I think one of the things that is going to excite a lot of developers is what we call generic subscripting, which of course tells everyone exactly what it is, right? I remember I saw, the patch goes in and goes like, what do you mean generic subscripting? What is this? What am I going to use this for? Well, it's something that can be used. It's generic because it can be used for all data types. It works the same way. The typical examples now are JSONB and HStore. And the idea here is that you're able to query these in a standard subscripting. So this is your typical JSONB, right, or JSON, just a faux colon bar. And this here is how you can now access it with these generic subscripting. It's a syntax that we're used to from other languages. That's typically how we access them. Exactly the same syntax now works for HStore. Whereas previously, each data type has had like its own different syntax for extracting keys from it. And we now have a generic way of doing it. That's going to make just life easier. And frankly, since we're used to this syntax in other languages and things, it makes your code a lot easier to read than some of these unusual operators that we have, particularly around the JSON data type, I'd say. We've added support for something called multi-ranges. These are range types, which I'm sure all of you know and love, If you don't, that's probably because you don't know them. If you know them, you will love them, right? The idea is multi-ranges is that in a single value, you can store multiple ranges. A range can be, it's a start and stop value for those of you that don't know the range type. So it can be a time range, for example, is a start time and a stop time. And you get an indexable access to this. So you can say, give me all the rows in the table where the start, where this timestamp falls between the start and the end, for example. And this will now work for multiple values in the same row with the same kind of index. And it's really easy to create them. You create them by just saying, create int4 multi-range will then be a set of multiple int4 ranges. All the ranges has to be of the same type in a multi-range. So you can't have one integer and one timestamp in the same. That would be very strange. And then you can store this, obviously. So you create it here. This will be a multi-range of 1 to 4 and 7 to 10, right? So it'll be stored as a single value, and a query lookup will find any value between 1 and 4 and 7 to 10, but it will not find 6, for example, if you're querying for this containment operator. So this makes our range types even more flexible and even more usable in that regard. We recently gained support for SQL standard stored procedures. They've been enhanced a bit more. Stored procedures themselves in the SQL standard stored procedure have been enhanced without parameters. We didn't have before. We've always had the functions that return parameters, but the SQL standard has procedures without parameters. Postgres now has this as well. And we have SQL standard function bodies that applies to both the stored procedures and functions, where you can, instead of using the standard Postgres way of declaring bodies, which can be dollar quoting, for example, as we're used to in Postgres, we can use the SQL standard way of doing it, which is to say begin atomic, because of course it has to be something else. This applies only to SQL language functions, but the difference between this and the classic way of doing it in Postgres is that these will be parsed at definition time, not at runtime, and Postgres will track dependencies inside of your functions. So today, if you have a function that references a table, right, you can go drop that table, and the function will stop working. If you are creating your functions using these begin atomic SQL standard syntax, when you try to drop the table, Postgres will say, no, this table is being referenced by a function. You have to say drop cascade if you want to get rid of it, and then you will also get rid of the function. Right. So you have the ability to do that, and it'll track that. Sometimes it's very convenient that Postgres does not track dependencies because you can just go make evil changes to your schema. But you can also break things really badly when you've missed the fact that there was a dependency. Somebody wrote a function and forgot to commit it somewhere or something, and you lost on that. So having the ability to track the dependencies can be a really, really valuable thing. Super cool. This might be a runner-up for the simplest feature that most people are going to love. It seems very simple. There is a function called dateBin.
With dependencies, what happens if you don't drop the table? You just alter the table.
On this one, well, it depends. If you just alter the table, you should be fine, right? The table is still there. It'll allow you to alter the table.
So you can still break the top code.
Well, if you're renaming the table, I think we track renames.
Yes, does it follow the same rules? Because otherwise when you rename, it will automatically rename.
I think when it stores the parsed value of the function, so I believe you rename the table, it'll actually rename it inside the function. But of course, you can probably find a way to change the table to break the function by changing data types or something.
Is there a schema binding? Meaning you reference that table and took a column, and that table can somehow store a procedure, and now you either rename the table or drop that column. Would that work or not?
If it's tracking the dependency, which is, the actual dependency is tracked on which table by object ID. It's not tracked by name. So if you drop it, it'll look at the object ID. If you have a masking table in a different schema, it's bound to the one that you're actually seeing, like when you create it.
Well, the question is, you're not dropping the table. You just, let's say you drop a column inside that table, and you reference that column in a different storage procedure.
So I will admit I'm not entirely sure if we track column dependencies. Does somebody want to answer that? Does anyone know? I know we track on the table itself. Yeah, but the question is whether we track on column dependencies in this stored procedure thing. I know we do it in general. I think we do. In which case, yeah, you will not be able to drop that column.
Okay, and if you set a search path in the procedure, will it still like?
If you set the search path in the procedure, that will be set when it's being parsed.
Not inside, but
Right, but at the creation of it, then
then also it will like so if you like also move it to the new schema, will it say something wrong or not?
if you move it to a new schema, that's
But it's like alter, like yeah.
I think if you move it to a new schema, I don't know. I'll have to try that. I don't know that one. If you rename it, it should follow the rename, but if you move it to a different schema, I don't know. It's still the same idea, but will it change the set schema in the function? Or set search path in the function? Yes. I will encourage you to try that and let me know. Because then I will be able to answer that question the next time. Okay, moving on to the date bin function. This is a way to let you group timestamps into a bin, right? It's a little bit like date trunc. If you've used that function, you can say date trunc, truncate all my timestamp to week, for example, and group by week. But it's a lot more flexible because you can choose the times. Like truncate lets you truncate to units, days, weeks, months, years. Date bin lets you specify one. So in this example here, you can also tell I made these slides for the Austrian conference, which I think was on like a day after this or something. But if I do select date bin, so the first parameter is the size of the bin. So here I'm saying take my time and split it up in buckets of 15 minutes each. Start it at this point here, 2021-01-01, and every timestamp since then gets split up into 15-minute buckets. And take now, which 15-minute bucket does now fall within? Well, in this case, it fell within the 2230 bucket on the 8th of September. And I can do, like, that actually makes sense. This probably makes less sense. I can also make my bin 17 minutes and 30 seconds long and slice all the time since then into those bins, and then it actually falls into the bucket that starts at 22:27:30 on that night, right? Okay, so there is a general level like between these two that still makes sense, but if you get to this level, I do wonder what you're doing. But being able to basically truncate and do this to get and group by this and get count per 4-hour block or something like that is, I think, going to be really, really useful. And when you look at the function itself, go like, okay, that's a very small thing, right? Yes, it is a small thing, but I think it's going to be super useful for anyone who does data analytics and stuff like that. And who would ever think you'd do that in like an SQL database? That's just weird, right? It's all just key value store. That's what we do. So I think that's going to be one of those simple features that a lot of people are really going to love. So, backup and replication. What have we done there? Not too much this time, but there are a few very important things. Further movings on this, you can now change the restore command without the restart of Postgres. One other, a couple of, was it version 12 when the recovery.conf parameters were moved into postgres.conf? And the promise was, as we do this, you're no longer going to have to restart for everything. And then as version 12 was released, you still had to restart for everything. But we've made primary coninfo, for example, changeable without a restart. Now also restore command. Really that simple. Change it, reload, everybody's happy. A bigger change can be what happens when you make incompatible parameter changes on your primary. Traditionally in Postgres, if you make an incompatible change on the primary, for example, if you go to your primary, you change your max connections from 100 to 200, and you restart the primary, now all your standbys crash. Because they will say, oops, this doesn't work, because the standby has to have at least as high a value for max connections as the primary. The difference in Postgres 14 is it can't keep running because the reason for this max connections, for example, is that like sizes of lock tables are sized based on this value. So it really has to be bigger, but instead of crashing, the standby will now pause. So it'll pause replication, similar to if it hit this max standby streaming delay or something like that. Let you go in, change it on the standby, and do a controlled restart of it, and then it'll just come up and keep running. So it pauses recovery. You still have to shut it down at some point, right? But you can do it in a more controlled fashion. Having the system just randomly die on you is usually not very popular. It'll just do it. Logical replication can now stream long transactions, is the feature name. Took me a while to realize exactly what this one means as well, and by default it's turned off. You can turn this on an individual subscription, so on the receiving side. And the idea here is basically that the subscriber will be able, like if you have large transactions that are streaming out your logical data, the subscriber will be able to receive all this data and buffer it in files on the subscriber side for large transactions, instead of having to keep it in memory and eventually spool it to files on the publisher side. Yes?
Quick question on your earlier, the PGConf copy.
Yes?
Is that going to reflect the percentage of time that your logic replication is doing on the standard copy out and sync between the groups on the subscriber?
That's a very good question. I think it should definitely do it on the receiving side where it writes in, because that one uses a regular copy. But I think it does. I think it should show up on the primary side as well. But I actually don't know that one either. This is good. I like these questions. These are questions that make me have to go look things up afterwards. That's a good challenge. Because, yeah, I agree. Logical replication, initial copy can be nerve-wracking. When it's running and you have no idea, it's been running for 4 hours, this is going to take another 3 days or 10 seconds. So let's take a look at a few of the things in the area of performance, because again, everyone loves performance. I'm going to start with this one because it's maybe the biggest one, and it's also one that I can't really fully explain, but there's something called snapshot scalability improvements, which is, you know, if you look at all the nice explanations and details, it looks super cool and very advanced, and I don't understand it. But it's much faster. We get significantly faster MVCC snapshots, particularly on systems with many CPUs. And it turns out we have a lot of those systems these days, right? These days where people were really cool when they had 4 CPU cores, like that's not really a big machine these days. We have a lot of CPUs, and Postgres has had a lot of overhead when calculating these MVCC snapshots, which are done at the beginning of every transaction or at the beginning of every statement, depending on your isolation level, which is very, very often. And in particularly if you have many sessions, so that means if your max connections is large, including if you have many idle sessions, so if you have a very large connection pool that is just not doing anything, calculating these snapshots could get very expensive on these systems. And the good thing about me not entirely understanding exactly how they're faster is that you don't have to do anything, they'll just be faster. And somebody else will have to fix the bugs in them. But it is, I mean, it takes a lot of work to make it done. It basically just means that if you have lots of sessions and lots of CPUs, Postgres is just going to run faster. Particularly if you run many short queries when, of course, the calculation of this snapshot becomes an increasingly large portion of the time that your system is doing. If you're running queries that take hours to run, then the overhead of the snapshot is probably not going to be measurable. We have some further updates and enhancements to the partitioning support. Yet again, we've been plugging away at that one for a number of versions now, and it's getting really good. Update and delete statements now gains the ability to do execution time partition pruning, or runtime partition pruning, as we call it. Selects gained this a couple of versions back, which particularly makes a big difference if you have a large number of partitions, right? Because Postgres will run a first run to eliminate partitions that you don't need when it plans and runs the query, or when it plans the query. But then when it runs the query, it might know more. For example, if the resolving of a subquery indicates which partitions can be eliminated, it'll do this second run and eliminate those partitions before it actually ends up running. And that now also applies to updates and deletes.
Will that increase the performance of the planning time as well? Because I've been in situations where we're getting 20, 30 millisecond response time, and we'll partition it, goes up to 300 milliseconds, you got to spend 150 milliseconds.
Yeah, I say 20, 30 seconds of plan time, that would be bad. It will affect it a bit, I believe, but it's not, like it doesn't remove that step. You still have the step at the plan.
It's a lot faster, actually.
But it is faster, right? And there are a number of other speed ups in this area as well. So I would expect it to be faster. It's not eliminated, but it is faster. And then, of course, being able to just not scan all those partitions once you do the updates is also very helpful. You can now do a non-blocking partition detach. You could already attach partitions concurrently, but you couldn't detach them again. I say this is one of those things, it's not something that you do very often, but when you do, it can be really painful. Right?
What about concurrent index? Not yet.
What about what?
Concurrently indexes on partition, not yet.
Create index concurrently?
Yes, on partition.
Yeah, there's been no changes in there yet. This is just detaching the partition from the partition tree completely and attaching a new one. So I guess, you could do a detach and create the index on the detach and then reattach it, but there's no, the simple way is not there. Our BRIN indexes, the block range indexes, now support multiple min-max pairs through a separate op class. If you know the BRIN index in general, the min-max version of the BRIN index works that the Postgres will take your table and split it up into block ranges. I believe the default is 128 pages of 8K, right? And then for each of those, it'll record the highest and the lowest value that exists within this range and store that in the index. So when you query, it can bypass and say, well, this thing I'm looking at cannot possibly be here because it's outside the highest, lowest range. And the way that these multiple min-max pairs allows you to say, for each of these blocks of 128 blocks, so that's a tunable since before, right? For each of these blocks, how many different combinations of min-max will we identify and store? And you can do it, you do it like this, basically, create your index using BRIN on this column, and then you say, int for min-max multi-ops, that is, I want multiple, and you say values per range 16. That means for each one of these 128 block ranges, it'll store 16 sets of min and max to be able to deal much better with data that is almost like, their general BRIN works really well if the data is perfectly ordered, because there will be like one min, one max, but if you get just a single value in there that's outside of this min and max, it can just throw off the whole index. By increasing the number of values per range, you can deal better with tables that are well ordered but not perfectly ordered. Right? Yes, Nick.
How is that different from reducing the block range size?
How it's different from reducing the number of blocks per step. Well, you might have a very large set of, well, let's just say the 128, but you may have values from 1 through 10 and 90 through 100 in it, and nothing in between, and it'll be able to identify that big gap in the middle and eliminate that. Whereas if you split it into sizes of 10, you would have many more entries in the index. So that's the idea behind it. Obviously, there are scenarios where it will not help any more than just changing the size of the block, but it gives us another tool in the flexibility of the BRIN indexes to use. Our window functions can now do incremental sorts. Incremental sorts were added previously in Postgres to deal with data that is partially sorted the way you want. Right? Older versions, really old versions of Postgres would just, or really old, it's not that long ago, but older versions would just, if your data was partially sorted, either by you had an index that covered part of the thing you wanted to sort, but not the whole thing, we wouldn't be able to use that. Or if one node in your query tree would produce data sorted by one thing, but you needed it sorted by two things, we also couldn't use the fact that it was already partially correct sort order. That's what incremental sort does. And we were able to do incremental sort for order by and group by previously, and in 14 we're now also able to do it in window functions. Our parallel query support has been extended. You can now, if you have a stored procedure, a stored function that does return query, that can now be parallelized, use parallel query. I know at least a couple of my customers who are really happy about this because they are using the pattern of having stored procedures for a lot of their complex queries, and they've not been able to use parallel query, and those are exactly the kind of queries that would typically need it. Now they can. Refresh materialized view can now use parallel query. Obviously also potentially a very big win because the whole reason we're using materialized views is that the underlying query is expensive. If it wasn't, we wouldn't need a materialized view. Foreign tables can now scan multiple foreign tables in parallel if the foreign data wrapper supports it. The Postgres foreign data wrapper does support it. That's also part of the things that were added in 14, unlike in some versions where we added the infrastructure and didn't get the time to add it to our own FTW. It is there now. Speaking of foreign tables now support inserts in bulk mode, so that if you insert many rows, it doesn't have to run them as individual inserts across the foreign data wrapper. It can insert multiple rows in bulk. We control that by setting the batch size. And foreign tables now support truncate, so you can truncate a table that sits on a different machine. Postgres has finally given up on just supporting our own built-in PG-LZ compression and added support for LZ4 compression. This is for toast tables. And as I say, LZ4 tends to always be faster and sometimes better. In fact, it's often better, but it's not always better compression than you had before, but it is always faster compression, and it is significantly faster compression. It is not just 5% faster. It is a much faster compression. You have a new parameter, default toast compression. Postgres still defaults to using PGLZ, which is the built-in one. You do need a separate library when you're compiling Postgres to do LZ4, but I think all the packages on Red Hat or Debian or Windows or whatever do support it. They've built it like that for you. But if you're building yourself, you do need to add that. You can change it on an individual table, alter table, alter column, set compression, LZ4. Or when you create it, you can just say, text, use this compression to override whatever you put into default toast compression. If you want to recompress all your data, well, have fun with that. We don't really have a way for you to do that. You can dump and load your table, whichever way you do it. We're even smart enough that if what you're trying to do, like, I'm going to create a new table with create table, new table, as select star from old table, that's not actually going to recompress your data. Postgres is smart enough to copy the old data over, which in this particular case was not what you wanted, but it is what it does.
We tried really hard to figure out a way to make it not do that, and there were corner cases we could not.
Yep, it is one of those things that sounds like it would be easy, but it turns out in reality it wasn't that easy. Like so many things in computers. libpq has received a pipeline mode that lets you send multiple queries before reading results. This is a libpq client thing only. Decreased latency. You still have sequential execution. We don't support parallel, like overlapping queries over the same connection. This is just about reducing the number of round trips and reducing the latency in the execution. And finally, before I run out of time, we've done some important changes to vacuum. Which Postgres release hasn't done important changes to vacuum, right? There are a couple of default values. One thing that's good to know is the vacuum cost page miss default value has been updated. Like many other of these things, it's something that probably should have been done a few years ago, but it hasn't. So you may consider changing that in older versions as well. You can now, if you're doing a manual vacuum, you can tell it to not bother vacuuming your toast tables, because you might know that you don't have to do that. Previously, the system would just always do that. There are some transparent things that are going to be very useful. We will be able to skip index vacuum in a lot more cases than before. Index vacuums is one of the most expensive things about the vacuum in Postgres, right? And previously, if you had literally just a single entry modified in an index, it would be triggered for an index vacuum, right? And then it would vacuum the whole index, which might be hundreds of gigabytes or terabytes, which is slow. The difference now is this magic constant of 2%. If less than 2% of the index has been touched, we can skip it. And why 2%? Because it's magic. And magic it's good magic, we hope. The idea here is we can then afford to vacuum more often to get the things that we really need to done, because the table vacuum is so much cheaper with the proper maps and things. There are also cases where we can recycle the B-tree pages immediately so that we don't even need to vacuum them. Previously, there were cases where we had to vacuum them twice. We'd have vacuumed them once to realize they were about to become empty, and then again before we could use them. Just an optimization to make that run faster. But that's going to help you a lot if you, particularly the first part here of skipping vacuum. If you have large indexes, vacuum will become much less painful. Speaking of painful vacuum, there is also something that I hope you will never have to run into, but if you do, you will be very happy it's there, I think. What we call a vacuum wraparound failsafe. If anyone's run into running out of XIDs and your system is about to shut down, you know the pain when you get there, right? And what this new, so there are two new parameters that default to 1.6 billion. They're vacuum failsafe age and vacuum multi-exact failsafe age. And they're basically saying, if your auto vacuum or whatever manual vacuum you're doing has left you at a point where you've reached 1.6 billion out of these 2 billion, right? And things aren't done yet, it's going to turn off this cost-based delay and start running vacuum as fast as it can. It's going to stop doing the regular vacuum and switch to just fixing this problem for you. So at this point, vacuum is going to run. It's going to start using a bunch more I/O than it was before. It's going to push your system harder. But hopefully, it's going to mean you're not going to hit the 2 billion transactions before it's done. Because if you hit the 2 billion transactions before it's done, you've lost. Right? That cannot possibly happen. Now, hopefully, you will never get there. Hopefully, you're among the people who will never get to this 1.6 billion before auto vacuum has cleared things up for you. But, sorry? These switches are, you set it to a value that by default is 1.6 billion. So I guess you can turn it off by setting it to 2.1 billion. And then, you get to keep all the pieces when it breaks. Don't do that. Unless you really know what you're doing.
The best part is there are going to be people who now hit the fail-safe, it engages, bails them out of trouble, then it goes back to being broken, and they just never realize it. They just keep running the system on the edge of disaster.
They probably are. But, you can say that about everything we try to help them with. At least it will save some people. And again, at least hopefully you will not be in a position where that happens, because it is not fun when you're looking at that transaction ID counter going up, and at the same time you're looking at your vacuum going very, very slowly forward, and you start calculating how much it's going to cost you when the whole system shuts down, because that is what will happen. Right? This is like this vacuum before you hit this 2 billion. This is in no way optional. You can't just postpone the problem. It will hurt. And this will make you take the pain a bit earlier at 1.6 instead of 2, but it makes you also, survive. It'll hurt you, but it will not kill you. And if you're lucky, your system was just badly tuned, in which case it won't even hurt you. It'll just run and finish because you had it badly tuned from the beginning. But the more common cases, it will hurt you when it hits, but it will not kill you. Yes?
So if somebody were to turn this down way closer to 0, would that be really bad?
Not really. I mean, you can turn this down to, 10 transactions. But you can also you can, but don't do it. But the better thing, if you actually want that, is just turn off cost-based delay for all your auto vacuums and have them run at this pace anyway. That's the better choice.
Doesn't it disable index vacuuming as well?
It disables a bunch of other things as well. Yes, it's not just that it turns off cost-based delay.
If you start using this mechanism all the time, you're going to notice things that you're not going to like.
Yeah, don't do that. If you want the effect of making vacuum run more aggressive already from the beginning, just turn off the cost-based delay. Yeah, exactly. It does freezing only.
thing to do actually when you run into a situation where you see, I'm accumulating more XRDs and more XRDs, is turning the cost-based delay down so that the net time is less, or the number of...
Well, yes. You read and think about which of those values go up and which go down. Because I've seen so many people realize they want to make a vacuum more aggressive and they change the value in the wrong direction and they make it half as aggressive because that seemed like the right thing. But no, the delay needs to go down or the cost needs to go up, not the other way around. So anyway, I hope that you will not run into this one. There is always going to be more. I think I'm already over time, so I'm going to have to let you guys head out to lunch. All I'll say until then, there will be more things. There are always a lot of small fixes, performance and everything. If you haven't already, please download Postgres 14, run it, test it, let us know. We can no longer say that we're going to fix the bugs that you find before we release it, but we will try to fix them before the next minor release. If you test them out, let us know, and then once you have that minor release out, you can go in production on it. All right, thank you all for listening. Go enjoy. I think it's lunch, so go enjoy lunch. Thank you.